Hi and welcome to the NumPy for Data Science Essentials course. In this Essentials course, we're going to talk about NumPy, what it is, and how we can work with it, what it represents, how powerful NumPy can get. So in this course, the NumPy for Data Science Essentials course, currently at the time of recording, we have just 3 sections. First one is going to be exploring multidimensional data. This is going to contain the basics of working with the NumPy package. What are arrays, how you can create arrays, what are different dimensions, what is a row, what is a column, and all of that basic yet cosmically important stuff. The second section is going to be complex indexing, and the third one is leveraging other libraries. So first, let's go ahead and let's jump into the first section of the NumPy for Data Science Essentials course within this Python Developer Bootcamp. This is so exciting, right? So let's just click on it and let's create our very first file. Now, before creating that, I have provided you with a folder called Data. Within the folder, you are going to have 4 CSV files: Titanic, Salary, GDP, gross domestic product for some countries, and then we have the ages. This is going to form the data that we are going to provide computations and analysis on. So make sure you have copied this with those 4 CSV files. Let's create our very first NumPy file. And we are going to name this Creating Multidimensional Arrays. So I'm just going to basically name that. Now, first, let me introduce you to NumPy. NumPy is a very awesome scientific computing package using all kinds of data analytics. NumPy supports a wide variety of mathematical computations, such as linear algebra, Fourier transform, random number capabilities, and so on. The basic building block used by NumPy is a very powerful n-dimensional array. The NumPy package, in addition to the ability to represent these n-dimensional arrays, also contains a whole suite of operations that can be performed very efficiently and effectively on these arrays. There is a suite of open source software available in the Python programming language for math, science, and engineering, and NumPy forms the core of this suite. Many of other packages such as Pandas, SciPy, Stats models, Scikit-image, Scikit-learn, Matplotlib, etc. are built on top of NumPy. So in addition to multidimensional array representations, NumPy offers a large collection of high-level mathematical functions which can operate on these arrays. So we have an ecosystem in NumPy. And let me introduce you to that ecosystem. In the ecosystem, we have packages such as Stats model, which is used for estimating statistical models and performing tests. We have Scikit-image, which is used for image manipulation and processing. We have Scikit-learn, a set of simple and efficient tools for machine learning in Python. This Scikit-learn package is the best library to get started with machine learning in Python for someone who has done no machine learning before, for someone who has no machine learning experience. That is a great starting point. Pandas for data analysis and manipulation, Matplotlib plotting library for 2D graphs and visualizations, and so many more. So just to wrap everything up, in theory, NumPy forms the basis of all of the mentioned libraries. The multidimensional NumPy array is the core building block which is used to represent data in all of these packages and libraries. The best way to learn NumPy is to get coding right away with NumPy, so let's just get started. Now, this course is going to be a highly example-oriented course. So we're going to have tens of examples, possibly like nearing 100 examples or more than that. So there is going to be a lot that we are going to cover. This is going to be one of the biggest essential courses, even though there are 3 sections, but there are going to be a lot of lectures in each of these sections. So let's just get started with NumPy. First, we're going to import NumPy as np. And let's create our very first array. So I'm going to call it first array. This is going to be equal to, so I'm going to grab the NumPy, and then there is an array method on it. This array method is going to accept a list. Within the list, you provide the content for your array, or the array elements. Let's take a look at our first array. So this has a type of array, and it has 4 elements within that array. Let's create a numbers array. Again, there's going to be like a ton of examples in this essentials course, in this NumPy course, because NumPy is highly practical, and I need to give you as many examples as I possibly can within the scope of this course. Let's create a list. So I'm going to say 11, 12, 22, 33, 44, 55, and 66. Let's create a second array. So I'm going to say second array, and you can just basically pass that list in here, and it is going to create an array for you, a NumPy array. So if I say second underscore array, it is going to grab its content from the list that we have provided. Let's take a look at the type of the array. So second array, and it is going to be a NumPy n-dimensional array. N dimensions, it means it could have any number of dimensions that there are. So it could be 1-dimensional, which is scalar, which it could be 2-dimensional, or more than that, which we call arrays in NumPy. We can also create an array of our desired shape through the zeros method. It is going to help us quickly initialize our array. So if I say zeros array, and I'm just going to say np.zeros. So what do you want the shape of this array to be? Specifically, how many rows do you want? How many columns do you want? The first number is going to represent the number of rows. So we want 3 rows and we want 4 columns. Let's take a look at this array. And np. Oh, there is an extra e. np.0, there we go. So we got 3 rows and we got 4 columns in here. We can also initialize our array to ones as well. So I'm going to say ones array, and np.ones is another cool method. Let's say this time I also want the shape to be 3 by 4. 3 by 4 means 3 rows, 4 columns. And that's just ones array. Just run it. There we go. So we have initialized it with 1. We can provide a specific data type for our arrays as well. You can specify the data type. So I'm going to say ones. You can see that these are floating point numbers, right? It is 1 dot. Can I zoom in a little bit more? There we go. So you can see 1 dot, 1 dot. So these are floating point numbers. Let's say you want to change that to integers. And I'm going to say ones array int np.ones. What do you want the shape to be? I want the shape to be an an array of 4 columns and 4 rows and 5 columns, and the d type or data type, I want it to be np.integer 16, integer 16-bit. Let's take a look at this. Just copy that and put it there. There we go. So it no longer contains those floating point numbers. We can also create an empty array. So I'm going to say empty array. np.empty method is going to provide us with an empty array, a 2 by 3 empty array. So let's take a look at that as well. There we go. So 2 rows, 2 by 3, 2 rows, 3 columns. We can also create a square matrix. A square matrix is when diagonally you're going to have the same number. So let's say it is also called an I array. So I'm going to say I array, and it is going to be np.eyi. and let's say you want it to have a length of 3. This 3 is going to be the length of those diagonal from top left to bottom right elements of the array. So let's create that. There we go. So it is 1, 1, and 1. Let's create another I array. So I'm just going to provide that here, and I'm going to change it to 6. There we go. So you can see from the top left, we are going to have 1 all the way to the bottom right. And the length of this is 6 columns, and then you have 6 rows, and then you are also going to have 6 columns. That's why it's called a square matrix. We can also create a matrix of even numbers. So let's say even nums in p dot a range. This a range functions. This is not a range. This is a range. So it's going to provide you with a range. So what does a range require? It certainly requires a starting point, which I'm just going to provide it 2. It definitely requires an ending point, which I'm going to provide it at 20. And it requires a step, right? I'm going to provide it as 2. So 2 starting point. I'm going to change the starting point to 4, so there is no confusion. And now let's just grab our even nums and print it. 4, 6, 8, 12, 10, 12, 14, 16, and 18. It's not going to contain the actual ending point, like the range function in Python. It works exactly like that. We can also change the step to be floating point numbers. So I'm going to say floats array. Floats array np.a range. The starting point is going to be 0. The ending point is going to be 10. The step is going to be 0.35. So let's grab that. Let's run it. So we got 0, 0.35, 7, 1.05, 1.4, 1.75, all the way to 9.8. Now that we know how arrays are created, all of the arrays that we have actually, not all of them, most of the arrays that we've actually created so far, they are one-dimensional array. Whenever you print an array, it's very easy to understand how many dimensions it has. So for that, I'm just going to zoom really in. So you can see the ending bracket, parenthesis, it is just 1. That's why it denotes a one-dimensional array. But whenever we created a 3x4 array, this is a two-dimensional array. Why? How do you know it has 2 dimensions? Because there is a row and then there is a column. And if you want to know that syntactically, there are 2 brackets. If there are 3 consecutive brackets, it's a 3-dimensional. If there are 10 consecutive brackets, it is a 10-dimensional array. So I have created a 2-dimensional array. So this is also a 2-dimensional array, but this one is a 1-dimensional array. So let's go ahead and let's create a 2-dimensional array on purpose. It's 2D, and I'm going to say np.array. So keep in mind, this is going to require only 1 argument. So you cannot provide it 2 arguments. If you want to provide 2 arguments, you need to provide it within this brackets. So the first dimension is going to have numbers 2, 4, and 6. The second dimension is going to have numbers 3, 5, and 7. This is a 2-dimensional array. So let's print it. Array, 2 dimensions. How many brackets are there? 2 dimensions. So this is the first dimensions, 2, 4, 6. And this is the 3, 5, 7. That is going to be the second dimension. The same thing that we have here is represented in here as well. So this is the first dimension that we have, which is going to be rows. And then we have all of these from the top to bottom, which is going to be the second dimension, which is columns. So this is a 2-dimensional array as well as this one. This is also a 2-dimensional array. We can also determine the shape of an array. So as if you have this array, how do you determine what is the shape of that? The shape of any array represents how many rows and columns there are. So what is the array, like what by what? So is it 2 by 3? Is it 10 by 50? What is that? So it is going to show you what the shape of the array is. So if I print the shape of this array, it's going to be a 2 by 3 array. There we go. So what does this mean? It means 2 rows and 3 columns. We can create an array first and then reshape it to our desired one. So I'm going to say np. Okay, come on, buddy. So I'm going to say np.arange. This is going to create an array for us ranging from 0 to less than 8, which is 7. Then we can change its shape. So how many elements there are? There are 4 elements. Keep this in mind, that the shape that you provided has to be compatible with the number of elements that you have. So there are 4 elements. You cannot create a, like let's say a 2 by 3 shape, because that is not compatible. You cannot create a 2 by 5 shape. You can create an 8 by 1, 1 by 8, 2 by 4, 4 by 2 shape. Because in those scenarios, when you multiply one dimension with another one, you're going to end up with 8. 2 times 5 is 10. That's why it's not going to be compatible and you're going to get an error. Now I'm going to say array nd, n dimensions, np.arange. So what is going to be the range? The range is going to be 8. And I'm going to grab the reshape function and I'm going to call it, if I can spell it correctly, reshape. So I'm going to reshape it into an array of 2 by 4. So if I take a look at array nd, it is a 2 by 4 array, which is a 2-dimensional. There are 2 brackets, 2-dimensional. We can also create another array from an existing one and filling it with any kind of data that we want. Let's say we want to fill it in with ones. How can we do that? So we have this array nd, n dimensions. Let's say I want to create an array of ones, and I'm going to say np.ones underscore like. So what do we want our ones to look like? We want them to look like the array nd. Let's take a look at the array ones, and whatever is the shape of the array nd, it's going to have that specific shape. So let's say if you have 80, then you're going to end up with, let's say you want to have 20 into 4. If you do this, and if you run this one, your array ones is going to look like that array nd. Let's run that again, and let's run this one again. With this, our creation of multidimensional arrays comes to an end. See you in the next lecture.